Hello all, my name is Ethan Schauer and I am a senior biochemistry major here at Santa Clara University. My thesis is titled Identification of Genotoxic Impurities using Capillary Electrophoresis. I conducted my research under Dr. Steven Soljak from the Chemistry and Biochemistry Department. The goal of my project was to use capillary electrophoresis as a robust, rapid, and affordable technique to identify genotoxins. The future goal would be to utilize this assay to detect trace levels of genotoxic impurities that arise during pharmaceutical development. Genotoxins are small molecules that interact with DNA and disrupt normal cellular processes, like DNA replication and mRNA transcription. Genotoxins can be carcinogenic, so it is important to identify and control them. My method of exploration was using capillary electrophoresis, which is an analytical chemistry technique that separates molecules based on their mass to charge ratio and effective radius. The schematic in Figure 1 shows the process of molecules traveling in the capillary moved by the applied voltage. When they pass the detector, this creates an electrophoreogram on the computer. The genotoxin that I studied is ethidium bromide, which is a known genotoxin that intercalates into double-stranded DNA, as shown in Figure 2. The results shown from my research in Figure 3 depict a dose-dependent decrease in the absorbance of double-stranded DNA as the concentration of ethidium bromide increased. Peak 1, the black line, has only DNA. Peaks 2 and 3, which are red and blue, have the same concentration of DNA as peak 1, but they have an increasing amount of ethidium bromide. When the peaks were integrated using a software, the results showed a significant decrease in absorption when the concentration of ethidium bromide increased. Additionally, these results were verified using fluorescence anisotropy, which is a common technique used to detect binding events between fluorescent molecules. Other papers had shown ethidium bromide could be seen intercalated into double-stranded DNA using fluorescence anisotropy, and the results were confirmed in Figure 4. This data from my research suggests that capillary electrophoresis is a viable technique for identifying certain genotoxins like ethidium bromide. However, this technique is limited in its sensitivity, and more genotoxins would need to be tested to broaden its usability. However, the results I found in my research show a preliminary step. The capillary electrophoresis is a worthwhile analytical technique in pursuing the control of genotoxins for the future of pharmaceutical development. I've enjoyed using this technique to study genotoxins, and hopefully this contributes to safer pharmaceuticals and cancer that would be prevented. Thank you for your time.